here, and I need to find the corresponding part on my similar shape, and that is right here. So we know line segment BC corresponds to WX. And notice how the line segment is labeled BC from the center to the out. So when we label the corresponding part, we do the same thing from the center to the outside point. So now we want to try an angle. We have angle A, which is right here, and I want the corresponding angle. Again, if I rotate it slightly, we end up with angle V being the corresponding part. And we can also do this with pictures. So I have a picture of a tree and a pole, and they both have shadows. And it looks like I need to find the corresponding parts. The shadow can correspond to the shadow of the tree can correspond to the shadow of the pole, and the tree and the pole are corresponding parts. So the pole corresponds, or the height of the pole corresponds to the height of the tree. And we're going to be doing some word problems that will have a description using shadows and flagpoles and trees and buildings and ladders, and that is when you want to get this picture in your head so you understand how to find corresponding parts. Once we understand how to do finding the corresponding parts, then we can find the ratio of those corresponding parts. And if you remember, a ratio is a comparison of two quantities. And in this case, we're going to have two shapes, and we need to find the corresponding part and write a ratio for the measurement of those parts. So I have two triangles here. We'll do that example in a minute. But the first thing we want to do is find the corresponding part. Then we're going to write a ratio for those corresponding parts. And then we simplify the ratio if we can. So let's try it with these two triangles. We want to know what the ratio of the line segment BC to its corresponding parts. Now remember, when you have a ratio, you're going to always see this word, to. That way you know, what two things am I comparing? So I look up here on my triangle, and I'm going to zoom in on it a bit so we can see it. And I see BC is on my larger triangle, and that is right here. And its corresponding part, now this triangle, we're going to have to rotate it to make it look the same. This angle is 100 degrees, this angle is 100 degrees, so if you flipped that triangle clockwise and laid it right on top of here and lined up those angles, you can see which parts correspond. So that means this corresponds to QR. Oops, that's not what I want to write there. I need a ratio there. So first I found out that it corresponds to QR. Now I can write a ratio from BC to QR. The measurement of BC is 6 centimeters. And when you write ratios, when you're comparing on figures, you write it with the colon. You can write it as a fraction and then turn it into a colon when you're done. But it's just as easy to start out and write 6 to 3. 6 to 3. Now that can be simplified by dividing both of those by 3. So when we simplify it, it becomes 2 to 1. So the ratio of the larger segment to the smaller segment is 2 to 1. So let's try that with line segment AC. Line segment AC is right here. I want to find the corresponding part for AC. Again, I'd have to rotate the triangle, and I can see that is my corresponding part. So I write a ratio of AC to PR. PR, that line segment. And AC is 8 centimeters and PR is 4 centimeters, and when we simplify it I can divide both of those by 4 and I get the same ratio. The reason I have the same ratio is because they are proportional figures. So if I make one side bigger by 2, then the other sides will be bigger by 2. That's how we proportionally make a figure smaller or larger. So now I want to know what the ratio of the tree to the small triangle is on this picture. So here's the tree, and there is the size of that tree, and I need to find the corresponding part in the smaller triangle. Here's the smaller triangle, and this part of the triangle is the tree, so this is its